copolymers. Copolymers are those polymers which are actually formed by more than one type of monomers. And in this we will basically focus on rubber, natural rubber and synthetic rubber. Actually natural rubber is obtained from latex of a tree. Now this natural rubber is actually not so useful because it is very soft, it dissolves in polar solvents, also it's softened on heating and it is affected by chemicals. So in order to improve its properties, we need to heat it with sulfur, which is known as vulcanization of rubber. So there is another type of rubber, vulcanized rubber. Apart from this, there are some rubbers which are synthesized in laboratory, and those are known as, yes, synthetic rubbers, Buna N. So let's start their study. Natural rubber. Actually, a natural rubber is a natural polymer. It is obtained from rubber tree latex. It possesses elastic properties. That means whenever it is stretched, it deforms its shape, and whenever the force is removed, it regains its shape. So natural rubber possesses elastic properties. It is also termed as elastomer, and it is manufactured from rubber latex. It is a linear polymer of isoprene. Isoprene is the monomer of this, and it is represented like CH3 C double bond C, this side CH2 and long chain, and then H, then CH2, then it would be CH2 here, C, CH3, double bond C, CH2, H. So this is how natural rubber is represented, which is actually polymer of isoprene 2-methyl-1,3-butadiene. Okay. Next is vulcanization of rubber. Actually, the natural rubber becomes soft at high temperature. We can say that it melts, and brittle at low temperature. It shows high water absorption capacity. It is soluble in non-polar solvents. It is non-resistant to the attacks of oxidizing agents, and that is why actually it is not proper for formation of articles. We cannot form any object like rubber tires or shoes using natural rubber because of its such type of properties that it becomes soft at high temperature and brittle at low temperature. It absorbs water. It is it dissolves in non-polar solvents. It is not resistant to the attack of oxidizing agents. And for improving its properties, we use a process which is known as vulcanization of rubber, in which actually rubber is heated in the presence of sulfur, because of which what happens that some cross linkage gets developed and rubber becomes hard, and now it can be used for the manufacturing of articles like tires, shoes or many other things. So what happens during vulcanization, that rubber is heated with yes, I told you it is heated with sulfur, and this type of structure is formed like CH2, C, CH3, CH, CH2 and a long chain this side also. On this side it combines with sulfur and carbon, CH2, CH3, CH, sulfur, CH2 and so on. So this is how cross-linking sulfur comes between the two chains, and cross-linking is formed because of introduction of sulfur, and now the rubber becomes hard, non-soluble and also resistant to the action of oxidizing agents. So now it can be used. To improve the physical properties of natural rubber, it is heated with mixture of sulfur and appropriate additive at a temperature range of this 373 to 415 Kelvin, and sulfur forms cross links at the reactive sides of the double bond, and thus rubber gets stiffened. This process is called vulcanization of rubber, as I told you. The next is a synthetic rubber, which is known as neoprene. We have studied about natural rubber, and now there is a synthetic rubber also. There are a number of synthetic rubbers. One of them is known as neoprene. and it is used in manufacturing of belts, jackets and hoses. And actually it is like this, CH2 triple bond C, here comes Cl, CH2. This compound is known as chloroprene. CH. Chloroprene. This chloroprene undergoes free radical polymerization. Free radical polymerization, and we get a polymer like CH2, CCl, CH, CH2N, which is known as neoprene. Okay, next is Buna S. It is another synthetic rubber, and actually it is extremely resistant to the wear and tear, and thus it is used in manufacturing of tires. So it is formed by combination of, yes, butadiene and styrene. We have studied about this in very starting of this chapter, that Buna S is formed by combination of two monomers. It is actually copolymer. It is formed by combination of butadiene and styrene, and that is why it is known as Buna S. Let's have a look at the reaction once again. Butadiene CH2 CH2. This is butadiene. This reacts with styrene, which is like this, CH double bond CH2, and the polymer formed is like this, CH2 CH double bond CH CH2 CH, benzene ring CH2, and so 1 2 3 4 5 6 and 1 2 3 4 5 6 carbon atoms here. So it is formed by combination of butadiene and styrene, known as Buna S or butadiene styrene copolymer. Next is Buna N, another synthetic rubber actually, and it is formed by copolymerization of 1,3-butadiene and acrylonitrile in the presence of peroxide catalyst, and it is resistant to the action of petrol, lubricating oil, organic solvents, and thus it is used for making oil seals, tank linings, etc. And what is actually a reaction here, that it is 1,3-butadiene and acrylonitrile. So the structure of monomers is CH2 CH CH double bond CH2 butadiene. It reacts with a number of CH2 double bond CHCl. This is CN actually, not Cl. Acrylonitrile. They both come together, undergo copolymerization to form the polymer CH2 CH double bond CH CH2 CH2 CH CN, which is known as Buna N. Now there is a solved problem. The polymer obtained when monomeric unit, this is undergoes polymerization. So if we see, this is actually CH 2 double bond C. It looks like, okay, if I write it once again in rearranged form, it would look like something CH2, this part, double bond CH Cl, actually it's CCl, erase, it's CCl, then CH double bond CH2, it is actually CH2, So CH2, CCl, CH, CH2. If this undergoes polymerization, we'll get CH2, CCl, triple bond, CH, CH2, which is actually neoprene. So correct option is A here. Next is Buna N synthetic rubber is copolymer of. We know very well that Buna N is found by butadiene and acrylonitrile. So we have to look for butadiene and acrylonitrile. This is actually butadiene and this is acrylonitrile. So correct option is C here. It is formed by combination of butadiene and acrylonitrile and that is why it is known as Buna N. So correct option is C here. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of askIITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask Experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on Get Answer, and you will be answered within 24 to 48 hours by our experts. So students, now we are aware of copolymers also. We studied about natural rubber, synthetic rubber, vulcanized rubber. So in this video, we started with polymers. In the first one, we mainly focused on classification of polymers based on their sources, their structure, based on the intermolecular forces and based on polymerization reaction. Then we moved to actually addition polymers. We studied about different mechanisms of addition polymers. We studied about different addition polymers also, like PVC, polythene, low density polythene, high density polythene. Then we moved to condensation polymers. We studied the mechanisms and different type of condensation polymers and also their uses, including nylon 6, nylon 6,6, polyamides, etc. And then we studied about copolymers, mainly rubbers, natural rubber and synthetic rubber. This was a very easy chapter. It does not have very high weightage, but whatever question which will be in that exam, that will be very easy. So go through this chapter. This is an easy chapter and you can score marks easily. So for more videos on physics, chemistry, biology and mathematics, stay tuned with Ask IITians. Let me finish with this. Thank you.